there's people on the floor that don't like you because of X, Y, and Z. That's okay. You'll still get promoted, you'll still do well on your reviews, as long as what you're doing aligns with what benefits the company and we're all aligned with. Don't worry about other people that have bad attitudes. They exist, but you still need to have a good attitude.
Hello and welcome to the Being an Engineer podcast. Justin Rittenhouse is our guest today. He's a mechanical engineer with a Ph.D. in structural mechanics, over a decade of industry experience, and a background spanning both academia and Fortune 500 companies. He's taught engineering at the university level, led complex R&D and manufacturing projects, and is the author of Secret Keys to a STEM Degree. Justin is passionate about helping engineers bridge the gap between school and industry, sharing real-world insights, hard-earned lessons, and strategies for overcoming self-doubt and building a successful engineering career. Justin, thank you so much for being with us today.
Awesome. Thank you for having me.
All right. Well, I'm excited to dig into this with you, Justin. Let's start with the standard question that I ask everyone in the beginning, which is, how did you decide to become an engineer?
I don't have a good story, so I'll tell you how, but I'll do a little backstory as well. If I was smarter when I was a kid, I would have knew I was going to be an engineer my whole life. I love Connects, which, by the way, are way better than Legos. Um,
I
I
remember Connects. I
yeah,
like those too.
it was so much fun. I was always very good at math. Very good at math. Like in ninth grade, I got like 113%. So there was like obvious signs I should have been an engineer, but I guess I wasn't smart enough to pick up on them. And then I went to college as a business major for like one semester. And then all the people I knew in college with me were engineering majors. So I'm pretty sure that's why I switched. Not a very good reason, but that's why I became an engineer. I was destined for it, but I didn't see it myself until later in life.
I think business and engineering share some common elements. They're both very logic driven. They both rely on numbers to make
Yeah,
good decisions. They both, at least if you're a good business person, you're doing testing, right?
that's true.
You're iterating through testing. So I think they share a lot. There's a lot in common there. Tell us a little bit about your journey post graduation. What have you been doing, and leading up to what are you doing right now?
So I've been through a few different companies. Um, I started out as an intern slash co-op at a company called Denso, which is automotive. I was in quality, R&D, in the test lab. From there, I went to a small company, less than like 80 people, um, called Glassmaster Controls. There, I was a project engineer and an engineering manager. I went to another company called J. Rettenmeyer. This is a food company, so I did automotive. Now I went to food. Um, I was there for a couple of years as a process engineer. I was also a professor in Ohio, which I'm a Michigan man, so not happy about the Ohio part, but I did live in Ohio for 2 years. Um, and then now I'm at Whirlpool as a new product development engineer.
Right. And one of the things we're going to talk about is a book that you wrote, The Secret Keys to a STEM Degree. We won't get too much into the details yet about that book, but why don't you give us just a little bit of background? Why did you feel it was necessary to write this? What was the impact you hoped it would have?
I thought it was necessary. A part of it was I kind of wanted to write a book. I thought it would be kind of cool to have a book out there, and it is kind of cool. Um, but why I thought this book in particular is from my background. I grew up very blue collar. I knew nothing about college or anything about college. Um, and this book is kind of like a hodgepodge of information I wish I knew. It has great information if you know nothing about college, and then obviously I went to college for my master's degree and a PhD, so I actually know a lot more than maybe your parents might. And I taught at a university for a couple of years, so I also know more than maybe your parents may know that did go to college. So it has someone can learn everything they need to know, and other people can learn even more than what they already know. It's a wealth of information that I thought students needed to have.
When you were going to school, chances are, like most of us, you had a certain expectation of what industry was going to be like. And those expectations may have been influenced by things that happened at school, or maybe your imagination just filled in the blanks. We've all had expectations of what's going to happen post-graduation. What are some expectations that you think a lot of students have that just aren't based in reality once they graduate and get into industry?
Um, First is, in some aspects, school is harder than industry. In other aspects, school is significantly easier than industry. One aspect where school is harder is probably technical problem solving, like actually doing math problems. Obviously, when you're in school, you do it throughout undergrad. You have homework on top of homework on top of homework, solving complex engineering problems. In the real world, solving complex problems is a very small part of what you do. Um, in the actual world, you have to kind of have to be a project manager as an engineer. You have to do some of the technical stuff, and then you also have to work with people that um, comes from all different walks of life. People react differently. You have to understand how to navigate people, and then also lead times and manufacturing issues. Like in school, you design something for a project and you're good to go. In reality, there's a lot of trade-off decisions that you have to make. Quality has to come into play. Obviously, in industry, cost has to come into play. And these are all variables that you have to make. And when you're in school, you're like, I think it costs what I want. I can make the best of the best, and we're all good to go. But that's not how reality actually comes into play.
Yeah, those are great points. I remember interviewing for my first full-time engineering job, and I can't remember exactly what the question was, but we started talking about, or I started talking about how I think it's so interesting how in engineering we use math to predict answers, right? There's always a solution that we can calculate. And the guys who were interviewing me, they were all pretty seasoned engineers, and I remember a few of them chuckling a little bit and kind of nodding their head a little bit side to side and saying something to the effect of, yeah, it would be nice if that was always the case. But oftentimes we're just kind of putting our thumb out there and how close does that look? And that was one of the things that surprised me, and I think surprised other students as well. Exactly what you said, like the amount of complex problem solving using like math and physics,
Mhm.
like it happens for sure, but it's not that, at least for many engineering jobs, it's not that frequent.
Yeah.
And that was a big surprise to me. Um, there was another one. Oh, it was just another experience I had recently. We recently interviewed someone and for a engineering role that we have here at Pipeline. And this was a student who's just about to graduate. So right now, well, I guess he has or is about to graduate in just a couple days. It's end of May right now, 2026. And so we're asking him about some tools that he's learned in college that are applicable to engineering. And it was very curious that Excel was not one of the tools that he mentioned learning. And so we asked him about that. We said, "Oh, how much experience do you have with Excel?" And it was so interesting that he kind of looked at us blankly and it was like, "What do you mean, Excel? I mean, I've opened it before. It's not really an engineering tool though." And that was that was another, and I remember graduating college and maybe being in a similar place, right? Like I knew what Excel was. I could enter data and do some very basic things, but I did not realize at all the degree to which I would use Excel as an engineer. Someone said, I don't know if this is apocryphal or not, but someone said that Excel is the most commonly used engineering software in the world. And I wouldn't doubt it for a second. But that was another thing that as a student, I didn't realize um, how important understanding Excel was.
Yeah, I actually tell my class, I actually change how I teach. I used to like normally engineering you use like Python or MATLAB or Octave, a programming language, which is what I use for undergrad and grad school. And then I was looking in industry, I realized every engineer uses Excel every day. Well, I shouldn't say every. Most engineers use Excel every single day. Very few actually program. So now when I teach classes, I tell them you can use Python, you can use MATLAB, and it kills me to say this, but I also now allow you to use Excel because the reality is you're all going to use Excel all the time.
Oh, I love that. I think that is such a practical insight and suggestion you're giving to these students, Justin. I see the same thing, students coming out with skills in MATLAB and Python, and the reality is we just hardly ever use, especially MATLAB. But every now and then we'll pick up Python for something. But man, I don't know that we've ever used MATLAB for anything at at Pipeline anyway. And the schools just they push MATLAB so hard. Every student
Yeah.
comes out knowing MATLAB, and I don't know.
I agree. That's why I now let them use Excel or spreadsheets program like Google Spreadsheets because that's what you're gonna be using someday.
Yeah. Well, what are some of the other oversights or even mistakes that you see students making these days?
I don't think they focus enough on their career, the long game, because we go to college for to get a job, right? We don't go to college to go to college. Um, so I know some don't know what they want to do, and that obviously makes it more difficult. But others do know what they want to do. So the whole college experience should be geared towards that. And what I mean by that is obviously try to get internships in fields that relate to what you want to do. But even within school, a lot of times professors will let you pick a project. Make sure that project isn't random. Make sure that project aligns with your career goals. And then, when you apply for jobs in that field, you can have that project on the education on your resume, and you can talk about it in an interview. Like, yeah, I designed X while I was in school, and this is how I did it. So align school with your career the best you can.
Great advice. Great practical advice. Yeah, whenever I'm interviewing someone, I don't really care what's on their resume. Frankly, I try not to read resumes these days.
Mm,
I want you to show me what you've actually done, right? Give me a
yeah.
project that you worked on. It's fine if it was a school project, a student project, or even a personal project. That's great, but show me how you've applied problem solving, right? And logical thinking and any engineering tools that you do know how to use. Show me what you've done. Don't just give me a resume. Okay, so let's go back to your book now, Secret Keys to a STEM Degree. What is one strategy, maybe it's the same one that you just shared, but maybe there's another one, a strategy from the book that you think a lot of students probably overlook, but actually will have a really big impact in their careers?
Yeah. So the strategy we just talked about in the book, but one strategy I want to talk about maybe won't have a huge impact on your career, but will have a huge impact on your life. And I think it's worth talking about is how many different scholarships there are. I talk
Mm.
about this in my book. I I forget the exact number, but it's like $100 million of scholarship money goes on awarded every year. And there are more scholarships than people think of. I've gotten some that you wouldn't think of, but I'll give two examples of ones you wouldn't think of. One, this one was semi-competitive, but I got a scholarship from my hometown. My hometown and the surrounding areas have scholarships you can apply for, these ones are competitive, but I'm only competing against people from my hometown and surrounding area. I'm not competing against the world. So it's significantly easier to get than other scholarships. And then another one, obviously I can't hide kind of the way I talk. It is what I is. And I'm born with a cleft palate and a cleft lip. I got a scholarship for that. Like,
Really?
yeah, like
Huh.
it's not very competitive. I was born with a cleft palate and a cleft lip. I applied for the scholarship and I got it. So my advice is to everyone, think about what makes you unique and look up scholarships. For most of them
Mhm.
won't be competitive because there's a smaller number of things that make you unique.
This is very timely advice. My son just graduated high school and
Awesome.
is going to start college in the fall in the engineering program. And I'm gonna buy your book and
Yes. Love
have
to
my
hear it.
son read it. I think, man, what perfect timing right now for him to start reading something like this. Um, yeah, I'll have to think a little bit more about what makes him unique. White upper middle class family. Not a whole lot of uniqueness so far. We'll have to brainstorm a little bit, maybe. Okay, going back to the academic environment, what have you found that makes students successful? Like, what separates the students who end up being very successful academically, and then as finding a job, a good job after college, versus the students who seem to maybe struggle a little bit more?
I think it comes from hard work. Obviously, if you do your homework, you do well in school, and normally people that do their homework often have more drive than those that don't. Not always, because people can have drives to do different things, but often have more drive to succeed in an academic environment, often have more drive to succeed in an engineering environment in the real world. So I think it comes down to the student themselves and are they doing their homework? If they're doing their homework, they probably want to succeed in an engineering environment, and they probably will.
What is, let's see, I'm trying to think about how to phrase this. So we talked about like MATLAB versus Excel, right? MATLAB gets taught in universities all the time. What engineers actually use day to day is Excel. What are some other gaps that you've seen where universities teach one thing, but industry is actually doing something else entirely?
Presentations. Um, I feel like there's a significant difference between a good presentation in school and a good presentation to like senior engineering leaders. In school, you kind of have more, maybe more detail, more technical detail to the presentation. But when you're presenting to a large group of 40, 50 people, especially when you have leaders in there, it needs to be very, very clear what you're presenting and what the results are very clear. Like, for example, if you're presenting a plot, you can't just necessarily have numbers on the plot. It's also good to have like some kind of shading in the background, like green, yellow, red, as in if the point is in the green, it meets spec. If it's in the yellow, it's within 10% of the limit. If it's in red, then you know it's from a limit. So you have to, the visuals on a PowerPoint need to be very clear and you should know what it means just by looking at it.
That's a great one. We have an Excel expert in our team. I mean, we're all kind of experts to one degree or another, but there's one guy in particular who's super good with Excel, and he makes it visual, to your point, right? This is Excel, not PowerPoint, but he is so good at making things visual, just like you said, like gradiented colors that
Yeah.
indicate different, levels of success or failure or whatever. So yeah, anything you can do to help your stakeholders, those to whom you're presenting, like catch the vision pretty quickly, just
Yeah.
at a glance, as opposed to having to sort through all these numbers and tables. All right, what am I even looking at? What does this mean? let's go post graduation now, and this brand new student graduate has moved into the workforce. What are some areas where they seem unprepared, or maybe well, let's just leave it at that. What are some areas that you think young engineers are most commonly unprepared for?
I will say this to start is they're all always unprepared. Like I tell students, we don't mechanical engineering in most engineering is such a broad term. It spans a lot, and there's no way of us knowing what you're going to end up doing in your career. So we teach you a foundation, and then when you go into industry, you build on the foundation. But we build you a foundation out of bedrock, and then you build your house on top of that. So because of that, you have a lot of knowledge spread out over a lot of things, and then you start to pipeline and learn a lot. So when you go into industry, note that we know you're coming right out of college. We don't. I don't want to say this in a way that sounds rude. We know you don't know a lot about what you're going to know. You're going to learn a lot very soon, and we know that. So, a make sure you're asking questions. Ask questions you don't understand, and ask questions until you do understand what we're doing, why we're doing it, so you can get up to speed quicker. If you don't ask questions, it's going to take you longer to learn. And then another thing, kind of like we talked about before, is trade-offs. They're always making different trade-offs. And then another is CAD would be another example that students can make things very, very good in CAD, but very few students know how to design things in CAD that can actually be made. Actually, manufacturability is one I think is very common for students to be lacking.
Yeah, yeah, that's a big one. Okay, so there's technical preparation, right? Like you can prepare by learning CAD and maybe do your best to understand how to use CAD to actually design for manufacturability. You can know all the physics equations, all that stuff, but there's another kind of preparation as well, right? There's like trying to think of the right term for it, mental preparation or psychological preparation, mindset. What are there any mindsets or mental preparation that you think new graduates are often lacking in?
Yeah, I would say thus navigating people. If you, depending on how you grew up, if you grew up in a white collar environment, um, and then you go into the real world and you have to work on the manufacturing floor, you're gonna have to work with many blue collar workers who are fantastic. I'm not belittling blue collar by any means. I'm blue collar myself, but some of them do have attitudes, and you have to be prepared for that. If you don't have the right mindset, they might break you. Depending on what company you work at and how mean they can get. So you have to be prepared for that. And what I remind them is, while you want to be nice and courteous to everyone, and obviously continue being nice, what matters is what you're doing. Is there alignment between you and your manager, and perhaps you and the floor manager? If there's people on the floor that don't like you because of X, Y, and Z, that's okay. You'll still get promoted, you'll still do well on your reviews, as long as what you're doing aligns with what benefits the company and we're all aligned with. Don't worry about other people that have bad attitudes. They exist, but you still need to have a good attitude.
Yeah, that not everyone is going to like you all of the time, right?
Yeah, one of my favorite quotes, which I love, is, "You can be the sweetest peach on the tree, but some people don't like peaches."
That's great. Yes, yes, isn't that the truth, right?
Yeah.
Okay. How about self-doubt? Any stories or situations that you can think of where maybe especially as a newer engineer, self-doubt showed up and you had to overcome that somehow?
Yeah, self-doubt is huge early on, and I don't think it ever goes away. At least it hasn't for me. I still have it occasionally, pretty regularly. Um, it goes down when you get more experience. Obviously, when you just jump into the real world, you're getting the term we often use, and you have to drink from a fire hose. You get a whole lot put at you really quickly, and you start doubting, like, man, I don't know if I can do all this. The reality is, you can. We've all done it. We're human. You're human. We can do it. You can do it. Um, it's just as you get more experience, things get easier, and some of that self doubt kind of suppresses.
Remember when I was a student and I was taking a physics class, I think it was electromagnetism, which was a particularly challenging class for not just me, but it was kind of a weeder class, I remember. And I was in the lab with a TA one day trying to understand some equation or some problem, and I just couldn't get it. And I was so frustrated. And I remembered something that a family friend had told me before I started my college career. He said that the school is really difficult, but just get through it. Once you're through school, the job is actually easier. And I remembered that at that moment because, man, I just wanted to give up. I thought this is too hard. I can't do it. And there was a lot of self-doubt, a lot of self-doubt. And in that moment, I remember having a choice. Like I could just quit, do something easier, get a degree in economics or yeah, whatever. I say economics just because I remember that was the shortest degree at the college that I attended. Anyway, I chose to, well, I remembered what this family friend had said, and I said, okay, I'm just gonna push through it. This sucks, but I'll tough through it and get through, and I did. And he was right. Once I got into industry, it was like you say, like easier in some ways, maybe more difficult in other ways. But overall, it was just more practical, right? Far less theory and much more practice. And that's for me, that was easier, I thought.
And like you were saying earlier, in industry, depending on really what you do, you don't often have to come up with an exact number. You come up with a roundabout number, and then you add a little bit to it, and you call it good.
Yeah, and then you test it, and if
Yeah,
it works, great. And if it doesn't, you add a little bit more.
yep, exactly.
All right. Well, let's talk about AI a little bit. Everyone's talking about AI these days. What uses have you found or do you think will become available with AI and engineering?
So I do think AI is a very useful tool. I think it's overblown or overhyped in many regards. Like, to be honest, I'm not remotely worried about AI taking my job. I'm just not. I could be wrong, but I'm not. I'm not worried about it. I do
Thank
think
goodness you're not a software engineer, right?
that is one of the things it is good at. Um, but mechanical engineering, I'm not remotely worried. But it is very good at writing code and just writing in general. So you can use it to proofread emails or help you write an email. Or I often write the email or the chat myself, and then sometimes I'll put it in AI and be like, grammar check this really quick or whatever. Uh, and then it's also very good at brainstorming. You'd be like, you have a problem, you're like, hey, what are solutions to this problem? It can spin out. Sometimes they're helpful, sometimes they're useless, but it can still help with brainstorming. So I think it's a useful tool and can help you move quicker, but I don't think it's replacing mechanical engineers anytime soon. Ever, actually. But
Yeah, I have to agree. I don't know if I would say ever, but no time soon for
yeah.
sure. How about in manufacturing? Have you found any useful applications for AI in manufacturing?
Yeah, I think it can be very useful in manufacturing. Um, a lot of times with manufacturing and people on the floor, we're not really, depending on really working the people you have, we're often not really looking to optimize the results. They click the machine to settings that seem to work, and they hit go, they hit stop and they leave, they go home and they collect the paycheck. What AI is helpful is now you don't need an engineer to kind of play around with the machine. You can collect data with many different sensors on a certain machine and not on the machine, like maybe humidity increases your throughput, maybe it doesn't, but also temperature sensors and stuff like that. And then you can have AI kind of look through that data and be like, hey, when we had this setting at this humidity, we produced way more, but at this humidity, in these settings, we actually had higher output. So you have the AI kind of you still need an engineer to go back through it once the AI gives them hints, but you can have the AI give them hints on how we can optimize throughput, where a normal operator may not be interested in doing that.
Yeah. Yeah. All right, great. I want to go back to your book just for a moment here. The book primarily is for students. Is there information in the book that non-students, so practicing engineers, would also find helpful or useful?
Yeah, there's some. The prime audience, as you said, is high school students and college students, but a part of that is still becoming a STEM worker. And for that, you have to apply for jobs. There's information there about applying for jobs. There's information there about resumes and how to do a good resume. And then I have a very tidbit at the end also on how you should always negotiate. Whatever salary they give you, normally they have room to go up a little bit. So you should always negotiate at least a tiny bit, because you can normally at least get a little bit more money. And then there's a whole chapter on stress and how to reduce stress and stuff like that. So I would say I'm completely making up the percentage, but 40% of the book applies for those not just in school, but those outside of school, maybe a little more. I think it's a very, very practical book.
Okay, so you mentioned stress. Now you're talking my love language here. Let's talk a little bit about stress and managing stress. What are some of the techniques, some of the pro tips that you are a proponent of?
The first one I would say is sleep. I actually looked up this heavily for the book, um, and you should be getting 7 to 9 hours of sleep every night. Not any less, not any more. 7 to 9. I shoot for 8 myself. And it's crazy how much better you are when you sleep. I forget, again, you'll have to read the book to get the actual stats, but there's been many studies, and one study was, I believe, people playing the keyboard, and they had one group practice more but sleep less. And they had another group actually sleep more but practice less. The group that um slept more were like 35% more accurate and like 17% faster. Them percentages might be off, but you get the gist.
Wow.
They were actually better with less practice because they slept a proper night's sleep. So sleep, and then obviously diet and exercise are both very important for stress. And then I have both information on that in the book as well. Eat meat, eat fruits, eat vegetables, eat whole foods, exercise. And then also, as far as school goes, some of this you can do depending on what school you go to. If you go to a small school, you have less options than a big school, but you can take classes at different time, meaning if you know a class is very hard, try to align that with easier classes. If you know a professor is very hard, either he tells you he's very hard, all the students tell you he's very hard, and I don't recommend ratemyprofessor.com by itself, but you can use that with talking to your friends and getting information in person to find out if a professor is very hard. And then again, if he is, line up his class with classes that are known to be easier. So don't stack hard classes together. And also manage your time well. So what do I mean by that is time management is important in college. It's, believe it or not, at least in my opinion, is even more important in industry. And you need to pick and choose when you go to the tech degree. You simply can't do everything amazingly. And what I mean by that is if you're doing a presentation and you're doing it to leadership or you have to present it on it at the end to the class, you should do that very, very, very well. If you have documentation that's only for you and you're the only one who's going to read it, it needs to be clear so you don't confuse yourself in the future, but you don't need to make it look amazing if no one's going to look at it. You write it down, you make it very clear with plenty of notes so you know what you mean in the future, and be done. You don't need to color code everything to an exact degree. You can spend that time doing other things. So make sure you know how to manage your time.
This is really wonderful, just fundamental, foundational, practical advice. I love this. Um, I assume a lot of this is in the book,
Yep.
which is just another reason that I want to get a copy and give it to my son and have him read it, because it's so interesting, right? Like being in industry, or having been an adult in society for a long time, we take so many of these things for granted, and we forget that there was a point in our past when we didn't know these things, right?
Yeah.
We weren't born with this knowledge. It was hard earned over years, and it can be really easy to forget that. And these young students that are coming up, they just haven't had the experience yet. They haven't had the opportunity to learn a lot of these things. So I love how practical the advice that you're giving is. Here at Pipeline, we have some core values. Core value number 2 is governed by productivity, not bureaucracy. And I just feel like all of these pieces of advice you're giving are very, very productive, and practical. I wanted to go back just briefly and touch on the sleep aspect. This is another one, just foundational advice, right? How do you
Yeah.
deal with stress? Get good sleep. Now, obviously, that we're oversimplifying a little bit,
Yeah.
but generally speaking, I would agree that is the best thing that you can do to deal with stress is get good sleep. And something that I have found helpful, layering on top of good sleep at night, is taking a short cat nap during the day, a
Mm.
little power nap. I'll lie down for 10, 20, maybe 25 minutes, not more than that. I don't want to actually fall asleep and zonk out, but just close my eyes and maybe almost fall asleep, get into that space where you're not quite awake, not quite asleep. And I find that, man, those can work wonders in
Yeah.
reducing stress, increasing clarity, productivity. I can push myself, and many days I do just work all day, but many days I'll take the little power nap in the middle, and I find that I can push myself through all day and just keep working and probably get down to only 50 or 60% effectiveness, productivity,
Yeah.
second half of the day. Or I can take that 25 minutes out, do a little power nap, and probably maintain, I don't know, 80% effectiveness for the rest of the day. So, like, the trade-off is, for me anyway, it's very clear that powering down for those 20, 25 minutes, it's well worth it, and it pays for itself, easily.
Yeah, for sure. I remember a couple of times in engineering school, we would stay up all night, and then we would lay. One time in particular, we set an alarm because we had class at like 7:50, and it was like 7:40. So we set an alarm for 10 minutes, and we took a cat nap on the computer room floor, and then we woke up and went to class.
I guess it's better than no sleep at all.
Yeah,
10 minutes. Yeah, I remember peers in school saying things like, well, I'll just sleep less, and I'll just
yeah.
sleep less, and so I can work more. And oh boy, it never
I
worked for me.
I used to say, like a lot of people say, I can sleep when I'm dead. I don't say that anymore. I've learned a lot since then. I now prioritize sleep. I can go back in time. I would have prioritized sleep earlier on, but back then I didn't think it was as important as I know it is.
Amen. Yep. Agree. All right. Let's see. We're gonna wrap it up here in just a minute or two. So, couple last questions. What is one thing that you have done, Justin, or seen done in industry, probably, to accelerate the speed of engineering?
Well, first one we kind of already talked about, which is using AI. AI, like I said, it can help you write faster. You can even put data into AI and have it help you evaluate it. You still have to do that yourself as well, but it's still a useful tool. And then understand when you have to analyze the same data, when it's useful to you to create a rubric of something. So a good example of this, if you get the same data from the test lab and you get it in often the same exact format, it would be wise to create a very, very good Excel sheet that can take because normally when you get data from the test lab, you get it often off the same piece of machine or the same, it has roughly the same output. So you can normally create a very good Excel sheet that can break that output out and create plots and stuff for you automatically. So if you have to do it a lot, take the time and invest and create a good Excel sheet that will automate it for you. If you only have to do it once or twice, then you probably only want to do it manually. Um, and then going back to what we talked about earlier, don't I get people can be shy and they don't want to ask a dumb question, which for the most part doesn't actually exist. You don't know what you don't know. I know a lot of I don't know a lot of things that are common sense to some people, but I also know a lot of things that are not common sense to other people. We all have our nuggets of knowledge. So don't be afraid to ask questions if you don't know. It's much better to ask the question up front, get clarity on what you're supposed to be doing, than doing something you're not supposed to be doing and then having to redo it. So make sure you know what you're doing.
Yeah, that's wonderful advice. Some younger engineers I've worked with, I think one of the lessons that they've had to learn is when enough is enough and when to ask
Mm,
for help, right?
yeah.
They spend just way too much time trying to solve something on their own that many other people on our team already know how to solve. For sure, you don't want to just ask how to do everything
Yeah.
because that's not good for you or the team in general. But, spend a little bit of time trying to figure it out on your own. And if it gets to the point where you're like, yeah, this is going to take hours or days, and someone else knows how to do this, just go ask someone how to do it. There's no shame in that. In fact, I'd say it's the other way around. Like there should be shame in not asking someone when the answer is readily available out there.
Yeah, and that's a very good point. I always tell my students, and um, if you ask me a question, it should not be the first thing, the answer should not immediately pop up on Google. If it does, I might not answer the question. You gotta do a little bit
Can I
more work
Google
than
that
that.
for you?
Yeah, exactly.
Yeah, right. Okay. All right. Well, Justin, we're gonna wrap things up here. Before we do, what is something that you are trying to learn, or a person that you're trying to meet? Maybe a subject matter expert, or a vendor that you're trying to meet, or a technology that you're trying to learn about. I'm hoping that you can share something that you're trying to find, or something you're trying to learn, and all of these wonderful people out in our audience who are listening to this episode, some of them might hear that and say, "Oh, I know the answer to that. I can help Justin with that." Is there anything like that that comes to mind that someone out there in the audience might be able to help you with?
So two things, um, it, not necessarily engineering, but similar, it relates to engineering for sure, would be leadership. I'm finally reading the famous book, is it How to Win Friends? I'm forgetting the name. How to Win Friends and Influence People. I'm finally reading that book. Um, so I want to know how to influence people from a leadership standpoint. And then two, marketing. As an engineer, I've always been kind of against marketing for what is obvious for a lot of engineers. But as someone that actually wrote a book and tried to get my book out there, you realize people can't buy what they don't know exists. So you have to do the marketing side of it as well. Even though as an engineer it kills me a little bit, it still is important. So leadership and how to market better are the two things I'm trying to learn today.
Wonderful, wonderful. I'll share one book with you right now that I read early on as I was starting to get into leadership, and it's called First Break All the Rules. And it's
Right.
mostly about management slash leadership, but that was a really great one that I read, First Break All the Rules. And then I have done a lot with marketing over the years. I'm going to send you a PowerPoint. This is an internal PowerPoint that I made for myself just to help clarify what marketing is and how to do it well. I'll send you a copy of that, Justin. And for everyone else out there, if you have tips or tricks or books or people that you know of that might be helpful for Justin in regards to leadership and marketing, by all means, please get in touch with him, which is a great segue to the final question of our time together, Justin. How can people get in touch with you?
I have really two options. One is of course LinkedIn. You can find me on LinkedIn. And then two, I have my website, which is my first name, last name, and then the letters Ph.D.com. So Justin Rittenhouse, Ph.D.com. And there you can contact me through my contact form. So LinkedIn or my website. But on a side note, when you told me first break all the rules, I wrote it down, and I think that's a good learning lesson for students. Write things down all the time. You will forget everything you do. When you'll forget a lot of stuff if you don't write it down. So if it's important, get it on paper.
Absolutely. That's another great pro tip that I use all the time is lists. Keep
Yeah,
lists of things. I use OneNote a lot. Sometimes I have like an email that's a draft email in my phone that I never send.
yeah,
I just use it to quickly write down, an idea or a thought, and then I refer back to it later. But yeah, keeping lists of various things has been tremendously powerful for me.
yeah. I always have at work. Every meeting I go to, even if I don't think I'm going to need it, I always have a pen and a pad of paper. Every single meeting. And then in my life outside of work, I use the notes app on my phone. Like I have probably 100, 200 notes in my notes app that randomly go off at certain times when I need to know, when I need to remember to do something.
Fantastic. All right, Justin. Well, this has been a really fun and just foundational discussion. Thank you so much for being on the show with us today and sharing all of your background and your experience. Any final thoughts before we sign off?
Um, I'll end on a quote. I don't know if you've heard of Les Brown, but he's my favorite motivational speaker. And his quote is, don't let someone else's opinion of you become your reality. Meaning it doesn't matter what other people think. What matters is your reality, and you can make your reality come true. I always like to remind, I said it in this podcast, I'm human, you're human, the person listening is human. Anything we can do or anything anyone else has done, you can do as well. You have to put in the work.
Maybe there's a future for you as a motivational speaker, Justin.
Maybe, maybe.
All right. Well, thank you again so much. This has been really wonderful.
Awesome. Thank you for having me. It was fun and exciting.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.